In session 65, we're going to be addressing monomials and their factors. In the last lesson, we looked at determining the greatest common factor for particular numbers. We also looked at how to figure out the factors for a number, especially its prime factors. Now we're going to take it one step further, and we are now having an algebraic phrase. Here we have a polynomial here, 15x squared. The question is, what are the different factors for 15x squared? Well, what we could do is go ahead and list some right here. Well, right off the bat, we know that 15 is being multiplied by x squared. So 15 and x squared are both factors. Well, let's break the 15 down. What times what equals 15? Well, 3 times 5 is 15. Then we could also break down our x squared to x times x. So if we take a look right here at this row, 3 times 5 times x is 15x squared. Why? 3 times 5 is 15. 15 times x is 15x. 15x times x is 15x squared. So 3, 5, x, and x are all factors of 15x squared. But we also have the ability to create different combinations here. Are these the only factors? Well, no, they're not, because we can combine some of our coefficients with our variables here. What do I mean by that? Well, how about if we combined a 3 with an x? So my question is 3x a factor of 15x squared? Is there some number that we can multiply 3x by to get us 15x squared? Well, let's take a look. We took care of the 3 and the x here. 3 times x is 3x. What are we left with? Well, we're left with 5 times x. Well, what is 5 times x? It's 5x. So we can see that 3x and 5x are also factors of this. So any combinations that we have, we can do. Well, let's just take it one step further. What if we had x times x? Is x squared a factor? Sure, because x squared times 15 gives us 15x squared. What if I take 3 and multiply it by x squared? Is 3x squared a factor? Sure it is, because 3x squared times 5 is 15x squared. Likewise, 5x squared. We can take our x times our x here, x squared times 5. Our 5x squared can be multiplied by a 3 to give us 15x squared. So you can see that there are many numerous kinds of combinations that we can do. But generally speaking, when you have a monomial like this, and remember a monomial is a special type of polynomial. Sometimes I use monomial and polynomial interchangeably, but this is in fact a polynomial as well as a monomial. But when you have a monomial, what you want to do to determine its factors is take a look, first of all, at its coefficient and find out what are the different factors of the coefficient. Well, the coefficient here is 15. So we found out that the only two factors other than 1 and 15 are 3 and 5. You then take your variable and you include it to its highest power, to the power, I shouldn't say its highest, just to the power that's listed there. You then break the variable down into factors. Well, x squared can be x times x. So once you have broken down your coefficient into its factors, its prime factors, and you've broken down your variable into its prime factors, you can then take any combination of those to come up with factors. One more here. Is 15 a factor? Sure it is, because 15 times x squared is 15x squared. And lastly, Is 15x a factor? Sure is, because 15x times x is 15x squared. So generally speaking, all we're after you to see here is that when you have a monomial, you break the coefficient down into prime factors. You take your variable, break it down into its prime factors, and then you can multiply these together in any order that you want, and you can come up with additional factors as well. Each of these here, 3x, 5x, 3x squared, 5, 5x squared, 3, 15x squared, 15x, x, all of those are factors of 15x squared. Now then, let's go ahead one step further and determine the greatest common factor for two different monomials. Here we have 16x to the fourth, and we have 24x to the third. The question is, what is the greatest common factor for 16x to the fourth and 24x to the third? Well, remember, the first thing you do is find your greatest common factor for the coefficients. This we ought to be able to do in our head. Our coefficient for the first monomial is 16. Our coefficient for the second one is 24. What is the greatest common factor of 16 and 24? Well, the greatest common factor is 8. Now that we've found the greatest common factor for the coefficient, we now go to the variable. We have x to the fourth, and we have x to the third. X to the third is a factor of x to the fourth, because x to the third times x to the first is x to the fourth. So what you do here is you take your variable, here our variable, here's x, and then you take the number, you take the degree of it that's the smallest. What's the smallest? X to the fourth or x to the third? Well, x to the third is. Therefore now, what we did is we found the greatest common factor of our coefficient, which was 8. We multiplied that by our greatest common factor of x to the third and x to the fourth. X to the third was the greatest common factor of that. So our answer is 8x to the third. 8x to the third is our greatest common factor of 16x to the fourth and 24x to the third. Let's take a look at our next one. 12xy and 6y squared. Remember, your first step is to find your greatest common factor with your coefficients. Our coefficients here are 12 and 6. Well, the greatest common factor there is just a 6. So we're going to take that and we're going to multiply it by our variable that we have in common. Well, we start off with an x here. We have x to the first here. Do we have any x's down here in our second monomial? No, we do not. Therefore, x is not going to be a common factor in these two monomials. Let's go to our next variable. Our next variable is y. We have y to the first here and y to the second down here. What is the greatest common factor between y to the first and y to the second? It's just simply y to the first, or y. And then when we multiply those two together, we get 6y. Let's take a look lastly here at 3x to the fourth and 7y to the third. First of all, we ask ourselves, what is the greatest common factor of the coefficients, 3 and 7? Well, 3 and 7 are both prime, so they don't have any common factors other than the number 1. What about x to the fourth and y to the third? We have an x variable up here, but we don't have an x variable down here. So x is not a common factor. X to any power is not a common factor. And then lastly, we have a y variable in the second one, but we don't have a y in the first one. Therefore, the variable y to any power does not have a common factor in both. So there's no common factor among our coefficients, and there is no common factor among each of our variables. our x variable and our y variable. Therefore, these two monomials do not have any common factors other than 1. And remember, when you have two monomials, or if you have two numbers where the only common factor that they have is the number 1, they are called relatively prime to each other. And that's what we have here as a quick review. Two monomials whose only common factor is 1 are relatively prime to each other. And then lastly, the greatest common factor of two or more monomials is going to be the product of the greatest common factor of the coefficients and then the greatest common factor of each variable to the highest power that it occurs within those comparisons. That will finish up then session 65.